Okay, today we're going to now talk about congruent figures. This is a 2-day lesson. We're going to start it today. Hopefully we get through everything I want to, but we'll be able to get through the most basic part of it. You'll get the gist of it, understanding what congruent means. So, real quick, I'll warm up. What word is used to describe figures that have the same size, same shape? Congruence, actually. There you go. It's kind of awesome that you're like, oh, we're talking about congruent. I bet it's congruent. But congruent definitely is one. Are there any other words? Well, similar. Same. Anything else? Copies, replicas. Okay. What do you think all these images have in common? I have cookie cutters. I have templates. We have stencils. We have stamps. Turn and talk with your neighbor 30 seconds. I'm going to give a sucker out to one person. I'm going to call them. What do you think all 3 or 4 of these, what do they have in common? Turn and talk. I'm going to rephrase that because you're totally right. They're with arts and crafts. But mathematically, think in a mathematical term. Kemper was totally right. He's like, well, they're all arts and crafts. Yeah. But let's think mathematically. All right. Isabel. Yeah, this is the cool thing. When I use any of these are all kind of the template makers. Let's say I take the dragonfly. And I made a bunch of cookies, and I laid out the cookie dough all out. And I take that dragonfly, and I stamp it down. I stamp it down. I stamp it down. All the cookies that I make are going to be the exact same size and shape. Do they have to all be facing the same direction? No, I could turn them, right? I mean, I could take a cookie and turn it sideways. Or if I had all my cookie dough laid out here, and I'm not going to use a dragonfly anymore, I'm going to use triangles. Let's say I had a triangle cut out there. I might have another triangle cut out here. They could be the same size and shape, just maybe turned a little bit. Same thing here. If I chose this flower, or if I chose the Y stencil, or if I chose this stamp, every time I use it, I'm going to get an exact copy. And when we say exact copy, remember, it might be turned, it might be located different places, but the size, the shape, and when I say shape, remember where everything's laid out, they're exactly the same. Nothing changed. That is going to be kind of what we're going to be working on today. So, what are some other things that you can think of that might make a congruent figure? That every time I use it, it gives me the exact same shape.
Like the measurements of it?
What do you mean?
Like if you were to measure like size of the shape.
Okay, so maybe a measurement. Kinda, but that's going to be more of a 1D shape, like a 1, like just looking at it flat, or a 2D plane. What else could I do that would make a copy of it that'd be exactly the same? Well,
a copy machine.
Copy machine?
Wait, what? That's a joke.
If I take your test and I put it in the copy machine, it's going to give me the exact copy. Anything else? Okay. Control C, and then I do Control V. So I copy and then I paste an image. It makes the exact same. Depends what you're doing. A hole punch. If I take a hole punch, it's just going to punch out the same hole sizes. 3-hole punch would do the same thing.
The best way to get out of plagiarism is you copy them and then blame them of copying you.
I'm going to skip on this part. So, here's what I need us to focus on today. I can understand the concept of congruent figures. Alright, here's what I need you guys to do. In your notebooks, math notebooks where we keep everything. Remember when we glued a ton of things? We are going to go to this page today.
All right. Great.
Oh, you guys, okay. And then I'll help you and we'll kind of set it all up today. Okay. We need it to. Alright. Okay. So here's our exploration. Do you not have this one either, Noah? Okay. That's alright. For our exploration, let's see if you guys can do this. Mine just moved because they made the copies different. Alright, it says exploration. Remember, exploration is where I want you guys to kind of be doing some of this and then seeing what you learn. So it says, for each pair of figures whose vertices are given below, draw the figures in a coordinate plane. Alright, so the first thing we're going to do is draw these in a coordinate plane. And then we're going to copy one of the pieces. We're going to get to that part later. Here's what I want you to do first. The very first one, we have, on here it should say 2.4 congruent figures exploration. You have this one. This is where I want you guys to look. You have two shapes. They're giving you two shapes. You'll see A, B, and C. So what kind of shape are we making? Triangle. There's only 3 points. You need to go ahead and plot these 3 points, label them, and then plot these 3 points and label them. Okay? That's step 1. We don't need, yeah, I will, but we don't need it yet. So, step 1, go ahead and plot your points so you make your 2 shapes. I'm going to come around to be seeing them. Not yet. Gentlemen, I should see these graphs by now. I've done 2 of mine. Yours should be going. It should just be blank. Both of them or just that one? Alright. Now, here's the first thing I'm going to do before we go to the next step. I've put down my 2 triangles, my 2 points. When I look at the 2, do I think they're congruent? You see? Me, personally, I would have said no. I mean, and I know the answer. I know what the answer is going to be. But personally, I'd say no. For some reason, I don't know if it's the way it's just sitting. To me, the red triangle I made looks smaller. Some of you, maybe you have a little bit different eye, and you're like, well, maybe the blue looks smaller. Or you're able to look at it and say, no, I can tell they're the same size. So we have to figure out a way. We don't want to just always use our eye on this and just say, oh, I think so. We want to know for sure. So there's two ways we're going to do that. The one way is the simple method that we are going to use. That's going to be helping. This is what I like. I need someone to tell me the answer for sure. That'll probably be a reward. You have to be able to tell me the answer and prove it to me. Here's your tracing paper. This was the second part of the explanation. It said, then copy one of the figures. So you want to copy them and label the points, and then see, can you turn it, can you flip it, can you do something to it to match up with the other one? So if you think they're the same size, you need to tell me they're the same size, but you have to be able to prove it to me. If you think they are not the same size, you need to be able to prove it to me. Yes? Oh, hold on. Did everyone get paper, Tracy? Alright.
I got it.
Oh, that's what. Okay, so the points are different.
What?
Dude, yes they are.
Relax.
So short. Oh my god.
Alright. Caitlin. So awkward. Kate, bring yours underneath here. Alright. Listen up to this. Follow, because this is how you are going to earn this. Gentlemen. Okay. First thing, I just don't put your paper on there yet. Kate. No, put that part. Not your tracing paper.
Oh, okay.
Okay. So, if we look at Kate's paper, she has her two. She's told me, yes, they are congruent. Okay, so put your tracing paper on.
I'll put it on.
Now, this is going to be the important part. How do we check to see if they're congruent? Now, Kate, what did you say you were able to do?
I was able to reflect it.
So we're not going to just say flip. We're going to use our math terms. We're going to reflect it. And when she reflected, okay, everyone can go ahead and do that. Here's a key question I'm going to ask you. This is where we're getting more advanced on this stuff. When she reflected, look at right up here. This is going to be my bonus question for the sucker because she's earning it right now. What is her reflection line? Where did she reflect? She reflected at?
Right at -2.
Perfect. Right here. Gentlemen, keep stopping because of us. I'm reflecting right along this line. That became her line of reflection. So the first thing I'm going to be saying when I'm proving this is I'm going to say, I don't want to use this color to write that, but I'm going to say, reflect at -2. So my axis for the y-axis is I'm going to reflect at -2. And now what did you do?
And then I just.
Okay, what do you mean you went up? How do we say I went up?
Math terms.
I'm sorry. You added.
Nope, hold on.
Changed the one.
What meant to move or slide? First lesson we did.
Chord transition.
Translate. So then we'd say we translated up 3. Dusty, please face forward. There's nothing you need back there while I'm doing this up here. Okay, this is what I'm asking you guys to be doing. Is 1, we're going to have this, and then I want you to be able to tell me if it's congruent, how did I get from one shape to the other? So when they copied it, I'm going to say, I took my blue triangle, I reflected at -2, so that means this line, this whole triangle flipped over there, and then I'm going to translate up 3. The nice thing is, if we were thinking and we were looking at what was happening, I should be able to look at my points and say, okay, from B to E. You can put your stuff down. From B to E, I need to be figuring out how do I go from one spot to another. I could have translated up and down first. That is where we are looking for things. Dusty, I think, said add 3. So if I really thought, I'm showing you guys this extra piece. If I would have said I translated all my pieces up, that means this would have still stayed at -5. But if I would have translated up 3, that would have been at -1. This one would have stayed at -5, but this would be at 4. So at -2, but -1. The reason I'm showing you this is if we're not able to graph something, where are connections going to be? The first thing is if I translate it up, here would have been my points. Now when I do my reflection, that first day we did reflections, we did them right on the y or x axis. And we said, oh, if I reflected on the y axis, my y stayed the same, my x flipped. Well, I'm still doing that. I'm using a y-axis. So my y would be staying the same, which, if we look here, the 4 stayed the same, the 4 stayed the same. But the reason the x didn't just flip from positive to negative, it did, but I was over 1, 2, and I have to double that. So I'm going to reflect it 4 over. So when I would go over, I should be able to get to my points of being over. Oh, I'd have to count from how far it is. This one was 1, 2, 3. He was 3 away from that line of reflection, so I'm going to have to double that and add 6 to my number. I know this is advanced, but some of you are probably getting it. So, here's what I want us to try next. I'm going to erase this because this is the advanced part. But, here's where you're going to get your next sucker. Graph number 2. Here's your new points. I need to see you graph these 3. I need you to graph those 3. And I need you to prove if the 2 are congruent. If they are, I need the same thing what Kate gave me. I reflected at some point, I translated at some point. Maybe I translated and I rotated. Maybe I rotated and reflected. Maybe I just did one of them. Okay, I'm going to pause for a minute. Do this. Turn and work with your neighbor. All right, pay attention to Donovan's up here. So Donovan has the 2 triangles drawn. And what did you do, Donovan?
I literally just
put it on the transportation table, and then I rotated it from 0, 0.
Harrison, Aiden. Next time I'm a mark explainer. When someone's explaining, I expect everyone's eyes up here. Okay, so we're repeating what he said because we had to stop real quick. He uses tracing paper. He actually traced both triangles. And then what did you do?
I went to 0, 0, and I rotated it 180 degrees.
Okay, now he rotated. So instead of saying turn, we're going to say rotate. And when he first did this with me, he said I turned twice. Well, instead, we're saying degrees, 180. But I got a question. Either you or Haley are right.
I'm right.
Haley thinks she's right. But he said he went clockwise, 180 degrees. Haley said she went counterclockwise. Also, he turned clockwise, he turned right, she turned left. Which one?
It's both.
Both. Evan, what do you think, bud?
I'm solving it, so.
It's both, because if you look
Okay,
at
Isabel? Oh, hold on. I got someone else explain, so I need everyone to listen to the explanation. Isabel? How can it be both? She went right, he went left.
Because they're both on opposite sides, so you can flip them either way.
Okay, so if I go right one turn, is that the same as you going left one turn?
Yes. It's just called inside the water.
So here's my sucker I'm holding up. If I go right one turn, is that the same as going left one turn?
No.
So how can this be the same? What's that mean?
You do a 2 turn instead of 1.
And why is that important?
They can say you got to do 2 turns because if you do 1 turn, it's not the same both sides.
What do you mean? Give me more. You guys are on the right track. Why is 2 turns the same? Good. The best way to explain this, Dusty, Aiden, the best way to explain that, 2 turns, remember, we're talking about 360 degrees for a circle, full turn. 2 turns is halfway. So, like, my sucker right now would be facing down. That's 180 degrees. If I went left, it still goes halfway. So, with this, we can have kind of absolute value between the two. If I turn right 90 degrees, that will equal the same as going left 270. The reason is, if you add them together, they get 360. So if I go right 180, I can go left 180. If I go right 270, I can go left 90. So either example would work. Now here's the other key thing. Don and I hit on this. Pay close attention to this because I'm going to use a pencil to model this. I'm going to steal your spotlight real quick. But when we rotated, we had to pay attention about where's our rotation. If I put my pen right here and I rotated my paper, 1, 2. I did 2 rotations. It didn't equal, did it? Now, I could do that, and then I'd have to translate. Or, I put my rotation right at 0, 0. In this, oh, my paper slipped. And it was able to equal the same. Awesome. All right, you have. I know. We have 1 left to do. Last one. 3 points. Gentlemen, pay attention. I will make a new seating placement for you guys on Monday. That's not working for me. I keep stopping and you don't have this done. Working on this. This one's done? Yeah. Okay. What's the answer? No, the next one that I'm asking you to be working on. Okay, that's what I'm saying right there. Okay.
Which one? This one?
Yep, do the third one. It's on the next page. You should have 1 more on the next page. Alright. Looking at. Oh, I went over one too many, didn't I? Orange, let's see. Alright. Now when I look at these. Okay. Are these two congruent? No. We can see that there's no way I can translate, rotate, or reflect. So, not congruent. Alright, here's what I want you guys to do. I know we did the last one kind of quick. It's okay. Not congruent, they weren't the same size, and we know because they're overlapping each other. Your homework. Last thing for you guys. Homework is still lesson 2.4. You have 1, 2, 3, 4, 5, 6 questions. Don't.
We're gonna finish our folder.
You guys can try it. We'll see what you get. Day 2.4, day 1.